Hello learners, I'm Mr. Saul, and today we're going to continue our lesson on types of soil. Now if you remember last time, there were three main types of soil. We had sand, silt, and clay. Can you guys remember any of the details about sand, silt, or clay? Let's pause for a second and share out anything that we remember about any of these types of soil. Do you remember how it looks, how it feels, anything like that? We'll be right back. All right, welcome back. So now we're going to continue our investigation about the three different types of soil. And fortunately, I have some of each right here. So here I have my bag of sand, here I have my bag of silt, and this is my bag of clay. So during this lesson, we're going to be able to dig into these and take a much closer look at what they have and what they are made out of. Now, when we're talking about different types of soil, we have to know the word particle. A particle is the smallest part of something. In fact, that's where the word part comes from. So the smallest particle of sand is called a grain of sand. These are usually made out of tiny, tiny little small rocks and shells. They're not going to get much smaller than they are already. So compared to, say, silt or clay, sand actually has pretty large particles. You know that if you go to the beach or if you've ever felt sand, it feels kind of rough and coarse and it can get everywhere. That's because it has those large grains or large particles. So the particle size of sand is large. Now, how about the hardness? Well, we know that sand is made out of tiny little pieces of rock and sand. And these little pieces, they're not really going to get much smaller than that. They're already as small as they're going to be. And as we know, rocks and shells and stuff, they're pretty hard as well. So the particle hardness of sand, how hard is the smallest piece of sand? It's actually pretty hard. You know that if you've ever gotten some sand stuck somewhere, like maybe in your shoe or something like that, and you know it can be really rough and irritating. That's because it has large particles that are very hard. Next up, let's talk about silt. Silt is that most common, the one that we'll see, and it's just that black earth, the one that's usually on the top. And this one feels very soft and fine. That's because those particles are just medium-sized particles. They're not as big as sand, not as tiny as clay. So just medium-sized particles of silt. And how hard are they? Well, when I feel this, it feels a little bit rough, but if I really push down on it, it stops being rough and just sort of mushes into my hand and will get my hand dirty. That's because these are also of medium hardness. They're a little bit hard at first, but once I really crush it up, it turns even smaller and smaller. So, silt has medium-sized particles and it's medium hardness. And if you already know what clay is, then go ahead and put your thumb up because I think you know where this is going. Clay has the smallest particle size. Very, very small. And clay is that really, really reddish brown one. And you can see in here that it gets very, very fine. This clay, the pieces of clay, are so, so tiny that they actually hold together really well and nothing can get past them. So, how hard are these particles of clay? Well, if you get some dry clay in your hands, this red stuff, I'm gonna try it here, and we'll take a closer look in a sec. But if I get some of these fine little powder of clay and I start rubbing it together, it gets so small that it even fits inside of my fingerprints on my hand. And that's so, so tiny that those particles are easily the smallest ones. So you can see there's a pretty neat pattern here. When we're talking about sand, silt, and clay, sand has the largest particle size and it's got the hardest particles. Silt, medium particle size, medium hardness. Clay, smallest particle size and smallest hardness, or not smallest hardness, silly Mr. Saul. They are the softest. Okay, so They're the softest type of clay because I can mush it down into my hand into a nice powder. They have the smallest particle size as well. Let's take a closer look at what's happening with each of these. I'm going to set up my camera and we'll be right back. All right, folks, we are back. I have my camera set up on a black piece of paper here. I have my magnifying glass so we can take a closer look at things. And we're going to do some sand first. So I'm going to put some sand on our paper here. And this will let us just get a really close look at what this sand is really made out of. So I'm going to use my magnifying glass, and you can see pretty clearly here that the sand is made out of tiny, tiny little particles. These particles are very small and kind of rough, and they'll even stick to my finger if I touch it against the sand. So here we can see those tiny particles. But what we're going to find out is that compared to some of these other ones, the sand particles are actually kind of large. So that's the sand, and we'll come back to the sand in a second. Let's go on to look at some silt. So here's some silt on a white background so we can see that. Here we see that the silt has a very small particle size. It's actually, even though it looks like it might be large, if I rub it in, we see that it almost goes away as it makes my finger dirty. That's because those tiny little pieces are being broken apart because they're not very hard. Remember, they're only of medium hardness. They're actually kind of soft, especially compared to the sand, which is made out of little rocks. Okay, let's move the silt out of the way. And then let's add some clay. Now remember, I said that clay has the smallest particle size and is also the softest. Well, does that look like the smallest particle size to anybody? No, it looks like it's, it looks like it's the biggest. Well, that's because this clay is stuck together, and what we need to do is start to break it apart. And when we do that, when we break it apart, that's kind of hard. What we're going to get is smaller and smaller particles. And these particles are so small that it almost disappears. And these can get smaller and smaller and smaller. And I can even break it up on my fingernail. And you see that it turns into a very, very fine powder. It's almost smooth in my fingers. That's because clay has the softest particle. It's easy to mush and break apart into smaller and smaller pieces, and it has the smallest pieces. So what does all this mean? Well, a lot of it has to do with how they handle water. So let's take a closer look at how each of these deals when we add water. Okay, I'm back. So our last experiment that I want to do is using this cup that I've poked a bunch of holes in. I don't know if you guys can see, but I poked a bunch of holes in the bottom of this cup. And here I have 1 cup of water and another cup to catch the water. So what we're going to do is I'm going to hold my cup over it like this so you guys can see. And then I'm going to take some of my sand and I'm going to pour the sand into my cup. Okay? So now, I don't know if you guys can see, my cup full of sand at the bottom still has holes in it. So what we're going to do is I'm going to hold it up over this, like this, and we're going to pour water in. And we're going to see in the first couple of seconds if we can get the full cup of water that I'm going to pour in, if we can get it back out. So what do you guys think? Do you think that this sand is going to hold a lot of the water, or is it going to let a lot of the water just pass through it? What's your prediction? What do you guess is going to happen? Let's find out. So pouring in 1 cup of water. All right. And looks like we're getting a good amount back out. You can see how slowly it's dripping, but it's coming. Next experiment, I have here my cup of silt, which you can see here. And I have my cup where we're going to pour it into, and my water. So let's see how much water the silt will hold and keep from coming out. So this one is dripping a little bit, but it looks like it's even less than what the sand was letting through. I wonder why this one would be letting through less water than the sand. You can see it's dripping, but not nearly as much as was dripping out with the sand. So why would the silt let through less water than the sand? I wonder if it has to do with the size of the particle. How much space would be in between large particles? How much space would be in between medium particles? How much space would there be in between smallest particles? Using what we know, can you predict if you think when we try clay, if it'll let through more water or less water than the others? We'll be right back while I set that up. Okay, so for our clay experiment, if you remember, the clay was coming out in these really big particles, and we know that clay actually has the smallest particles. So I need to take these and break them down into their very smallest piece before we put them in the cup. So give me just a second. I'm going to take out some of these larger clay particles, and I'm just going to use something I have lying around to smash them into little pieces. All right, I think that's gonna be pretty good. So now we have our clay particles in their finest size, and we're gonna go ahead and pour that into the cup. All right, and we can see here, it is covering the whole bottom. So let's see how much water will come out when we try it with the clay. Here we go, 1 cup of water going in. There's like 5 drops of water coming out. Almost nothing. Ooh, and it looks orange if we look inside. All right, so this is weird. So almost no water came out when we put it in the clay. So what does that tell us about each of these? Why don't you guys take a moment to discuss? Remember, you want to think about how big the particle size is and the particle hardness. When you're thinking about how much water can pass through, think about how much space is in between a couple of large particles, a couple of medium particles, or a couple of the smallest particles. If I have 2 large particles, there's plenty of room for water in between. Medium ones are closer together, and tiny ones are going to be right up against each other. So think about why those would block water from passing through. I hope you guys had a great time learning about sand, silt, and clay. And I'll see you guys next time.